three-phase connection, how the power will be measured, and here the objective therefore to verify the relationship between the uh, voltages and currents of a three-phase circuit and to calculate the power for three-phase circuit. So here this is the three-phase experiment, huh? Sorry, experiment with three-phase supply. Understood? So you can see R, Y, B written. R phase, Y phase,
Ma'am,
B
slide
phase.
is not visible.
Ma'am,
Ma'am,
board is
slide
not
is not
visible.
Whiteboard is loaded.
Yes, ma'am.
Ma'am, we can't see the slides.
Okay, so just wait, just wait. Maybe network problem. Yes, network issue.
Ma'am, your
that's
presentation stopped.
Okay, okay.
Beach.
Okay, just wait for a minute, huh?
Yes, ma'am.
Just wait for a minute. Yes. Just
Okay.
Ma'am, do you provide us all the slides?
Ma'am, will you upload this presentation on MS Teams?
Ma'am, you are muted.
Ma'am, you are not audible.
Ma'am, you are not audible.
Ma'am, you are muted.
Ma'am, you are not audible.
slides visible?
Yes, ma'am.
Yes, ma'am.
Thank you
Yes,
very
ma'am.
much.
Yes, ma'am.
Yes, ma'am.
Acha. So this is with three-phase connection. Three-phase supply will be provided, and the
You are muted, ma'am.
Ma'am, again you are
Ma'am, you are muted.
Again, you are muted.
doing this, I think. Yes, no audible.
audible.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Slides visible.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So this is with three-phase connection. So you can see three rheostats. I'm coming to rheostat part. Huh? So three rheostats that would be first time connected with the. Let me show you. Can you see?
Ma'am.
Yes, ma'am.
Yes,
ma'am.
ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am. Star morning.
Star.
Now it's black.
Is this okay? All of you?
Yes, ma'am.
Yes, ma'am.
Yes,
ma'am.
Yes,
ma'am.
ma'am.
Yes,
So they will be connected like this. This three rheostat.
Yes, ma'am.
That's it. And we will measure what would be the power power for this circuit, three-phase circuit. Is it okay now?
Yes,
And there
ma'am.
will be a neutral wire.
Yes, ma'am.
Okay.
Yes, ma'am.
Yes, ma'am.
Next is experiment number 7. Characteristics of different types of incandescent lamps. So what would be the lamps considered over here? Here the tungsten and carbon lamp. Achha, what is the specialty of the carbon lamp? Do you know?
No, ma'am.
They are
No,
good
ma'am.
conductors. No, ma'am.
No, ma'am.
No, ma'am.
Negative
No, ma'am.
resistance coefficient. Have you heard?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
In semiconductor.
No, ma'am.
Resistance which decreases with
So
temperature.
here we will study. Yes.
They are
Yes,
high
ma'am.
nature
To
carbon.
study the volt ampere, power voltage, resistance voltage characteristics of tungsten and carbon lamp. and as well as the nonlinear characteristics of the tungsten lamp. That means when it is voltage is increasing and voltage is decreasing, then we will see two different, that means the path followed by the tungsten lamp when voltage is decreasing will not be followed. So that nonlinearity property we will also study over here. Understood? Next and the last experiment is this to study the series and parallel RLC circuit. So you can see over here, this is the laboratory setup. Huh?
Ma'am, can you show the previous experiment once more?
Yes, obviously. Why not? Yes, this is the board. This is the variac in our laboratory. AC voltage, the resistance. These are the two lamps. Individually, we will study them. Understood?
Yes, ma'am. Got it. Thank you.
And voltmeter and ammeter also shown over here. Now here, the capacitance, inductance, resistances. They will be connected first in series and they will be connected in parallel after that. And we will measure what? The power factor. Obviously, the supply voltage, current, voltage across each of them. Okay, when it is in series, then the current obviously will be same, but the voltage across them will be different. But when they will be in parallel, then what will happen? The current in each of them will differ from each other. So all we measure, and as well as the power and power factor. And obviously, after that, we will draw the phasor diagram. So what is phasor diagram, power factor, everything will be discussed in your theory class. Now next, what our objective is to show you some glimpses of the sources, rheostats, meters, etc. So first of all, you can see over here, I'm starting from the right hand side part. This is the DC supply. Okay. So what is the supply given over here? The voltage you can see, read voltage here and the current here. The supply voltage and supply current, you can read it from here. When it will be on, it will, and if you can increase this, there will be a knob. So the voltage ultimately will increase and you can get the reading from here. So how much voltage you are providing to your system or to the networks or circuits you are dealing with, you can measure it from here. So here it is known as the variac. It is nothing but an auto transformer, and here these 2 points where from which you will connect the network will be connected across them. So this 2, so wire will be connected here and another wire will be here, and this 2 will go to the network. Okay, so this is for the AC this is the AC supply. Understood, everybody?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Next,
Yes, ma'am. Yes.
next
Yes,
is
ma'am.
the
Yes, ma'am.
rheostat. Rheostat is for providing or having resistances in our network. It has got, first of all, you look at this 2 point. This 2 terminals, if you connect one terminal with a wire and this terminal, then the total resistance will, the resistance is shown here. This is the resistance. This is the resistance. The whole resistance will come across this 2 terminal. Now we can get extra benefit from the rheostat. How? We can vary the resistance. Suppose it is a 30 ohm rheostat, but we don't want to have 30 ohm for our circuit. Suppose you want to have some fraction of that, suppose 10 ohm. And this is the variable terminal. Suppose you connect one of the wire here and say another here. So the connection will be such that the current flow from here to here through this jockey, it will come over here, and then this terminal will go to the other part of the circuitry. So this much resistance will come into the picture. Now there is if there is, so this is the fixed point and this is the variable point. and you can move this jockey to vary the resistance. Now another connection is possible, and that is for the variable connection, variable resistance. This is the variable point and this is the fixed point. Now if you connect one wire here and another wire here, so across this to this the resistance will appear. How? It will start from here through this, then it will having, can you follow? Are you following, students?
Yes, ma'am.
So this
Yes, ma'am.
portion will come.
Yes, ma'am.
Yes,
So
ma'am.
this portion of the rheostat will come. So what will happen? This portion, suppose we are saying that alpha, that much alpha, the total resistance is R. This is alpha R. So this rest amount will be obviously 1 minus alpha into R. So that will appear. Understood? So by that way,
Yes, ma'am.
so that is why a rheostat is always preferable in the what it is in the electrical network. Next, coming to the ammeter and voltmeter. These are called moving coils. So moving coil is for the DC measurement. So you see over here the uniform scale. Now this is the, sorry. Hello.
Yes,
Am I
ma'am.
connected?
Yes, ma'am.
Am I connected to you?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
Yes, ma'am.
Yes,
Yes,
ma'am. So this is the common point, and this is 2 ampere. I think this is 3 ampere now. Sorry, 1 ampere and 2 ampere. Very sorry.
Ma'am, that is 1 ampere, 2 ampere.
1 ampere and 2 ampere. This is 1 ampere. This is 2 ampere, right? So the lower scale is 0 to 1 ampere, and the upper scale is 0 to 2 ampere. Suppose your current, you have an anticipation that the current can be in the range of say 1.5 to 2. So which scale do you prefer? Obviously the upper scale. So you will connect
scale.
one wire here and another wire at the 2. Okay, so but if you know your current is not that much high, say less than 1, so you will choose obviously the lower scale, so the connection will be common and this 1 ampere. Similar way, for the DC voltmeter, you have the common and 2 scale. I think it is 150, 300. Huh? So upper scale 0 to 150 and lower scale, and upper scale will be 0 to 300. So according to your anticipation, you will choose the scale and you will get the reading. And look at the scale. It is uniform throughout. Understood? So each 0 to 1 and
Ma'am,
each is
please repeat.
0, 0.1, 0.2, 0.3, 0.4, and the upper scale is 0, 0.2, 0.4, 0.8, like that. It is going to 2. On the contrary, for the AC measurement, moving iron instruments are used. And is it visible to you? The initial part,
Yes,
the
ma'am.
lower end is cramped.
Yes,
It is
ma'am.
not uniform at all. So by looking at the scale, if it is not written AC, by looking at the scale, you can easily identify that it is a moving iron instrument and it is used for AC measurement. So this is the ammeter and this is the voltmeter. Okay. So these are used in our laboratory. Achha. Next, to show you how a voltmeter is connected for measurement of voltage across 2 terminals in a network. Suppose for this particular circuit, here across C and D, we want to measure the voltage. So obviously, as I have already told you, one point will be connected to the, one terminal will be connected to the common and another will be obviously connected to one of this according to your anticipation that how much voltage you can get it. Suppose it is crossing this one, the higher limit, that means it is more than that. So you can change the lower to higher one. Suppose 150 to 300. Now it is, the indicator is showing that it is going to the rightmost end. So now you change it. Clear?
Yes, ma'am.
Yes,
Yes,
ma'am.
ma'am.
Yes, ma'am.
Yes, ma'am.
how to connect ammeter for measurement of any branch current. So ammeter always connected in series. So suppose we want to measure the current flowing, the current I1 minus I2 flowing through this 5 ohm resistor. Okay, so what we will do, we want to put it in the ammeter in the series. So therefore this point is connected to the common, and this point is connected to any of this range. Here also the same statement, that if it is crossing this side, that means higher end, that means you have to change the change it to the higher scale, right? Next is how to connect wattmeter for measurement of active power. Okay, now here most interestingly, wattmeter obviously take care of the voltage and current. So for voltage, there is a voltage coil or pressure coil and current coil. Voltage coil always will be in parallel like voltmeter, and current coil will be in series. Am I connected to you? Hello, hello.
Yes,
Yes,
ma'am.
ma'am.
Yes,
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 ma'am.
ma'am.
Thank you.
Yes, ma'am.
Yes, ma'am. Yes,
Yes,
ma'am.
ma'am.
Thank you. Please, please.
Yes, ma'am.
Yes,
Okay.
ma'am.
So can you, so from here, this is the wattmeter connection, huh? Schematic diagram. So here this is the current coil and this is the pressure coil. So this 2 point is shorted. So here you can see this aim point is here. This is C point. This is the apparatus used in our laboratory for, this is known as the wattmeter. Watts, it is written over here. See, so this two are shorted. So this line is shown over here. Please mute yourself, please. And this L point is here. M across M and L terminal, the pressure, the current coil is connected, and across C and V, the pressure coil or the voltage coil is connected. So V point is here. So that's why the connection you can see. Aim
Ma'am,
is
explain
here.
the terminology, ma'am. VLMC means the full form.
C is the common, I think, huh? And V is for the voltage. Acha. So L is connected to this line. This line. So it is L. So this is connected over here. This is V and this is this two, M and L. This is how
Ma'am,
our
what
wattmeter is
L and
connected.
M?
ma'am, can you explain it from starting
Which
again?
2 points are
Acha,
acting
ठीक है.
as voltmeter?
Acha. So aim
Ma'am,
part is
background
coming.
sound is coming actually from your
Acha.
side.
Yes, ma'am. That's right.
See. Suppose there is a resistance or inductance or any impedance is connected over here. Anything, RL or RC, whatever be. We want to measure the active
Now
power.
a lot of background noise is coming. We cannot hear properly.
Background noise. Background.
Abhirup.
Hello.
Yes, ma'am.
Yes, ma'am.
Acha. So here wattmeter means voltage and current. Okay. So voltage we need to measure as well as the current. So there are two coils associated with that. One is pressure coil, another is
and current coil.
another coil is current coil. So which one is the current coil? Here, and this is the pressure coil. It is in parallel. Understood? Can you see the schematic
Yes,
diagram?
ma'am.
Which is pressure
Yes,
coil?
ma'am. Yes, ma'am.
Yes, ma'am.
This one.
Yes, ma'am.
And this is the current coil, right? Right? Okay. So here, this is the
There is
aim.
lag between your voice and the
Ma'am, there is lag.
There is lag between your
Yes, ma'am.
voice and the movement.
I'm extremely sorry. I'm extremely sorry for that. It may be due to network problem. I am trying my best. Okay, students, can I continue?
Ma'am, use dark pointer to notice whatever the written here or there.
This is aim. This
Okay, ma'am.
aim point. Aim point. This is the line. It is connected here. This one. And this is C, common point. So aim and C, these two are shorted because we are connecting the pressure coil across the load and the current coil in series with the load. Understood? Clear? So this is connected. This is shorted, and this is the so across C and B, the pressure coil is there. So the pressure coil inside here, and that is here the outer terminal is shown over here. Understood?
What is the importance of pressure coil?
What is the impedance?
Pressure
Here,
coil.
here
What is
our
the
objective
importance
is
of
to
pressure coil?
show you the connection
Impedance,
of
it
the.
is importance
What is pressure coil?
for pressure coil.
It is for it is the wattmeter inside coil which is used for getting the measurement of the pressure, so that the wattmeter as a whole is giving the reading of the wattage. Understood?
Okay.
Through wattmeter you cannot get separately the voltage and current. For that you have the voltmeter and ammeter respectively. But wattmeter is giving you the how much wattage for of the load consumed by the load. Understood?
Okay, ma'am.
Achha. Another one is the energy meter. So here energy meter also there you can see over here. I think the faculty concerned for this experiment will explain you in better manner in elaborately, obviously. So here also again the AML CB points are there, 1 2 3 4 you can see over here. Okay, AM and L here and C and B here, and this 1 2 3 4 points are shown over here, where 2 3 are shorted and 1 is here and 4 is here. So across 1 and 4 the pressure coil, this current coil is connected, and this C and B the pressure coil is connected. So this is the standard meter, which we have in our lab. Okay, so so this is the end of the presentation, and obviously we will provide you so that you
Okay,
can
ma'am.
get. Okay.
Ma'am, you will
Okay,
provide
ma'am.
with the recording as well, right?
Yes.
Okay.
Yes. Other
And there is
members, other faculty members, please continue.
Ma'am, any reference book?
These are from my side. Yes, a reference book, Hughes is there. I think electrical technology.
The manual will be provided. There is
The
also
manual will be
reference
provided
book.
to you.
There will find out the reference book will also be written there. So will be
Electrical.
Ma'am, please turn off the recording so that it can be saved. We cannot turn it off tomorrow.
Other teachers,
Yes, ma'am.
please,
Please share
other
the
faculty
recording in
members,
MS Teams.
other faculty members, please. Anuruddha sir, Aritru sir, Rajdeep, Tushar sir, Boris sir, please, if you want to say something, please. Hello? Hello? Hello?
Yes, ma'am.
Yes, ma'am. You are audible, ma'am.
So if you want to add something, please.
Ma'am, they are students.
Anuruddha sir, Tushar sir, do you want to add something?
Ma'am, it is okay. Nothing from my side.
Is it okay?
Yes, ma'am. It is okay.
So ask Tushar sir, Anuruddha sir.
Tushar sir is there. I think Tushar sir can add some point, no more point if he wants.
Yes, Tushar sir, please. Tushar sir.
Anuruddha sir is also there. Aritro De sir is also there.
Aritro? Boris sir?
Yes, ma'am. Yes, ma'am. I will see. I will see if Tushar sir is there. Ma'am, it is fine. No issue.